All right, linear equations and functions. First off, we got to start talking about objective one, which is graphing linear equations in two variables. And there's lots of different ways to do this. First off, we need to talk about standard form or general form. Standard form is ax plus by equals c. Typically speaking, a, b, and c are integers. In this book, they talk about them as real numbers. A and b both can't be 0, but we want to put the x term and the b term on the left, the constant term on the right. And note that in order to be linear, a has to be raised to the first and y has to be raised to the first degree. So that's standard form. We're going to get into putting equations in standard form later. What you're going to see when I do them is that a and b are going to be integers and a is going to be positive most of the time. In this section, they say they just need to be real numbers, so they're not as picky. So one of the ways, of course, that you can graph a linear equation is just to make a table of values to find points on a line. And that's your old standard XY table. You pick values for X, find out Y, pick values for Y, find out X, those kind of things. Finding the values, plotting points on a graph, and then graphing them. Okay. Oftentimes, the X and Y intercepts are the best ones to use, the easiest to use, because if you plug 0 in for X to find the Y intercept, then it's easy to find the Y. Plug 0 in for Y to find the X intercept, it's usually easy to find the X, and you've done that before, and that's the way I'm going to focus on when we graph these. Then you plot both of those points, connect the dots, and you've got your line. Please know when you're doing this, do not make hand-drawn graphs. Notability allows you to make perfectly straight lines, so there's some great tools there. Grab a grid, use graph paper Notability, but don't do it by hand. Those tools that are already built into Notability are really cool, and we should use them. The other thing that we're going to be doing here is we're going to be converting equations into slope-intercept form, and we can graph them using the y-intercept and the slope. We're going to discuss that a little more later. So when it comes to graphing equations, you can either come up with points. If you remember, and hopefully you do, you remember how to put things in slope-intercept form, and you can graph the y-intercept, then use the slope to find other points. You're welcome to do that too. I'm going to go over that here in a little bit. But if you remember how to do that, then you're already in good shape. And those will be the primary ways that we'll use to graph linear functions. Okay. I'm not going to tell you which one you have to use. You're going to eventually need to know how to do both anyway, so it's probably good to give yourself a refresher on this. But we're going to talk about some other things here in a sec. Objective 2 is slope. And if you remember the slope formula, y2 minus y1 over x2 minus x1, slope, we use m to represent the slope. That's the steepness or flatness of a line. As a line goes up from left to right, it will be positive, and if a line falls from left to right, it will be negative. And we'll talk about those things. You can find slope from a graph. I'm going to go through this fairly quickly, but here's what's important. You want to find 2 points that go exactly through a set of grid marks. Like, for example, don't use that point. While we know the y value is 2, I would have to guess at what the x value would be, so that's a bad point. On this particular graph, there's 3 or 4 that are pretty good. These 2 are the ones I'm going to use. I'm going to use this point negative 2, 4, and this point 0, 1. The line absolutely goes through grid marks there. There's no guessing, and then we can find the slope that way. So I can use those 2 points, negative 2, 4, 0, 1, plug it into the slope formula, and it doesn't really matter which one you consider 0.1 or 0.2. You just have to start from the same one every time. So for this one, I'm going to follow it. So 1 minus 4. Remember, the y's go on top. 1 minus 4. Since I started here for that y's, I got to start here for the x's. 0 minus negative 2. So that obviously turns into plus 2. This gives me negative 3 over 2, which does equal negative 3 over 2. So you can put the negative there, you can put the negative there, or you can put it out in front, just so long as there's only one negative sign. Okay, that's the way to find the slope using the slope formula. Hopefully you remember how to do that. We can also find the slope just from the graph. And so you can count vertically and horizontally from one point to the other. Whether you start here and work your way down here, or this way, or start here and work your way up, it doesn't matter. remember that up and right is positive, left and down is negative, so I just count. And so I'm going to go this way. I'm going to go from the bottom point, I'm going to go up, so I go directly up 3, so that's positive 3. Then to get over to the other point, I have to go left 2, so that's negative 2, okay, which gives me negative 3 over 2. If I went from here to here, I'd go down 3, right 2, and so that would be negative 3, positive 2, still gets me the same thing, okay? So that's a refresher on how to use slope to find, how to find the slope, or how to use points on a line to find the slope, okay? And since it does fall from the left to the right, goes down from left to the right, it makes sense, hopefully to you, that the slope is negative. So let's look at some other things in this section. There are a couple unique slope situations that we want to talk about. And when I have a vertical line going straight up and down, okay, so vertical line like this, okay, it has no slope, right? No slope at all. It's always going to be x equals some constant. There's not going to be a y value. For a horizontal line, it's just going to be there's not going to be an x. It's going to look like this. Okay, that has 0 slope. And if you think about the slope formula, right, there's always the y values will subtract and give me 0, and it gives me a 0 on top. For the vertical line situation, the 0 is on the bottom, which means you can't divide by 0, which is why we say it has no slope or it's undefined. Okay, so those are the unique situations there. Let's look at objective 3, which is slope-intercept form, which I'm sure you remember. And in order to write a linear equation, all you need is the slope and the y-intercept. If you have the slope and the y-intercept, we can write a linear equation. And so let's talk about what slope-intercept form is. Okay, if you recall, y equals mx plus b. M is the slope, b is the y-intercept. So if I have those two things, I can just substitute in for m and in for b, and I'll have an equation. Okay, and the equations are, the types of problems are simple enough as it starts off. We say, all right, so write an equation. Slope is 6, y-intercept is negative 7. Go ahead and do that, pause it, and then come back. So in this case, slope, or m, is 6, y-intercept is negative 7, so my equation is y equals 6x minus 7. Simple enough. One of the things the book is also going to ask you to do, and we'll talk about this here in a minute, is also put this in standard form. So get it in ax plus by equals c form, and that's just a matter of rearranging the equation so the x and y are on the same side. Okay, there's other types of problems. Sometimes you're going to be given the slope, but you're not going to be given the y-intercept. And so you can still write an equation if you're also given a point. So you've always got to be given two things in order to write an equation. At the end of the day, if you're given a slope and a y-intercept, or if you have the slope and the y-intercept, you can write an equation. But you got to be given two things, whether it's a slope and a point that's on the line, whether it's 2 points, or a slope and a y-intercept. So any of those combinations, and we're going to look at all three of those different combinations and different ways to do that. So if you're given a slope and a point of a line, you can find the y-intercept. And so essentially what we're talking about is a problem like this. So we've got an equation, slope equals 3. It goes through the point 2, 8. So now we're supposed to write an equation for that. Well, we don't know the y-intercept, so we're going to have to find it. So here's what I have to start with. I have this, well, first off, which do I have? Do I have the slope or the y-intercept? Of course I have the slope. Okay, so the slope is 3, so m equals 3. So here's what I have so far. Y equals 3x plus b. Okay, and so since I have a point, 2, 8, I also have an x and a y, so I can find b. So essentially all I'm going to do is I'm going to plug this point into the equation and solve for b. So here's where we go. And since any point represents an x and a y, we substitute those values in for x and y in the equation and solve for b. So here's that. Okay, so the 2 goes in for x, the 8 goes in for y, and here I'm at. So 8 equals 3 times 2 plus b. This, of course, means that b must equal 2. So then I go back to this part, and I've got my y equals 3x plus 2. And so I've written that equation in slope-intercept form, and we're in good shape. So that's one way to do a problem like this. Later on in this section, or it might even be the next section. Yeah, in the next section we'll talk about point slope formula. If you remember that, we're going to get into that in the next section, but this section we're going to keep going this way. The last thing we're going to do is if we're given 2 points. You can find the slope first, so then pick one of the points to plug in. So the process that we just went through. So first thing is you're going to find the slope using the slope formula if you're given 2 points. So just like we did at the objective 2 beginning of that. You've got these 2 points, use the slope formula to find the slope. Then you've got y equals whatever the slope is times x plus b. Then you pick one of the points. One of those 2 points, you pick one, plug it in, doesn't matter which one because they're both on the line. And do the same thing that we just did. And it doesn't matter which point you choose. You'll get the same y-intercept the way we just did it on the last problem. You'll get your b, and you don't have to do it twice. You just have to do it once, and it doesn't matter which point you choose. Just pick one of them, and then you'll have your equation. So that's a quick little refresher of slope-intercept form, general form. We're going to get more into that at 2.5, but hopefully this all seems familiar, and you'll do great at it.